I always use an example of birds in a room to describe IR and NMR spectrum. If you are using IR spectrum, you are blind, which means you can hear the birds beeping but not be able to see them. You won't be able to see where the birds are, what are the color of the birds, or how many birds there are. You may be able to tell the difference of the birds by the sound, but you are not 100% sure about it. If you are using NMR spectrum, which we'll talk about in the next 3 weeks, week 6 to week 8, you are not blind, which means you can see everything in the room. Maybe there is a cat hiding in the corner of the room that you are not able to hear from the sound. What do I mean here is you might see more functional groups or structures from NMR spectrum, which you are not able to see in IR spectrum. But this week, we are just going to concentrate it on IR spectrum. Background knowledge, introduction. So in this paragraph, although it might scare some of the people if you have learned physical chemistry a little bit, we are circled here. They are vibration modes. So covalent bond share electrons between non-metal atoms, and then these vibrations. Okay, so just that's the two words that you should keep in mind. So first is covalent bond, and second is those are vibration mode. On your discussion menu, it says it's going to stretch, which means the bond in between is going to stretch. It behaves like a spring, so that's the stretching. So my two atoms is go back and forth between, or wagging, which means each atom is just wagging in the original place. And the symmetrical stretching, which happens to the three bonds, that's they are going to all stretch out. So the blue, maybe this. So the blue bonded to the blue atom is going to stretch this way, while the purple is going to stretch that way. So they're symmetric. Or they can just go in the other direction of those stretching. So rocking means they are all go in the same way, like this. Seasoning means they're closing like that. And wagging out of the plane means this is the plane of the paper. They are wagging out. Twisting means they are wagging in different directions. Okay, so let's come back here. 8 different kind of modes. They are all vibration. So this paragraph are some introduction, which the only things that you should keep in mind is the range and the units. So the range of wave number, okay, these two words, range, the range of IR, so that's usually from 4,000 to 400 centimeters, minus centimeters. So why this is go from 4,000 to 400? Shouldn't it be the other way around? No, because we are talking about wave number. So wave number is proportional to the frequency. So that's why it's always ranked from 4,000 to 400. That's something that you just need to know that. So this is the reduced mass. For example, you have carbon and you have hydrogen, but it's not going to be as simple as you add the mass of carbon and hydrogen together. Then you need to plug in. So carbon is M1 here. Hydrogen is M2 here. You need to plug in that, and you're going to get a reduced mass. And you plug in the reduced mass into the calculation. You probably need to know a little bit about how the machine works. Here, this is actually a simplified mode of the machine. Probably the only thing you need to know from here is before each trial, you need to get a reference. If your sample is not air sensitive, then you can just take air as your reference. So what we are measuring is actually the signal difference between your sample and the reference you set. So far, it's just the background of the IR. We only expect you to know some fundamental knowledge, such as what is the wave number and what's the relationship between wave number and the frequency. So from now on, that's something important, interpreting IR. So basically, those analytical person or physical chemistry person, they're going to figure out how it works, and they're going to go settle down those calculations and stuff. as an organic chemist, the only thing you need to know is use it and interpret. Okay, interpret those spectrum information. So now here is still the 4,000. So this is actually a small number. Okay, so keep in mind because it's in the denominator, and this 500 is actually a large number. Then you're going to see each functional group is going to behave differently. They will have different energies in those bonds, and they will appear in the places accordingly. So for example, something with H, so XH here, usually that's just OH or NH. Okay, and then triple bond usually just appear in the region of these two, in this region. Double bond, so this is triple bond. This is just double bond. The reason that they write X here, because X can be C or can be N. Here, X can be C or can be O. So that's the reason. And usually we ignore the fingerprint region. Basically, you only need to pay attention to the range from 1500 to 1400. So that's the region that you really need to look into. And there are only certain functional groups that is going to appear in those regions. I always describe this like you are still blind because you don't know where the bird is. You just know there's a bird. So the table on your discussion menu is going to be a dictionary. I hope you use it when you want to check if you have the functional group fall in the range of this. I don't want you to memorize any of the number. You just need to have a general idea of what the range is. There are 4 major regions, okay? So this is more useful than a table because that's where you are going to check. So in the region of 2700 to 1400, so you see that it's actually the 4 regions that's listed here, okay? So in those regions, you're going to see blah, 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 blah stuff. So basically OH, NH, and something related to OH and NH, okay? So in the region of this, you are going to see triple bond. So this is actually carbon-carbon triple bond, carbon-nitrogen triple bond. And in the range of fingerprints, which is the region that we usually don't check, unless you're doing a very specific project. There are people who have done it before and told you that this peak represents blah, blah, blah. Just for the fundamental organic chemistry, like 118 that you're taking. Usually you just ignore. So ignore this. So from 2700 to 1400, okay, here. And you can also see aldehyde. So this one, the one here, is the aldehyde, and something else like this one is the triple bond. So we are talking about this bond, and we're talking about this bond here. So although they are falling in the same region, but as you can see here, if we are talking about the bond, the CH bond next to the triple bond, it's going to be sharp. If it's OH, so this bond, OH stretching, is actually going to be bored. Even going to be border if you have a carbonyl next to your OH. Aldehyde peak is usually here. So although they have similar range, but they're going to look different. 2 that are both rather bored and connect to the center near 3300. That's primary amine. And because primary amine, the nitrogen here is gonna to have two peak. If it's secondary, which means if it's R prime nitrogen R, there's only 1 hydrogen, then you're only going to see 1 peak. So generally, our expectation for you to learn in this discussion is be able to identify some of the functional group from IR spectrum. So let's get some practice. Maybe just compound A and B for a few minutes. First thing you do, we don't need to read fingerprints region. Ignore that for now, okay? Second, let's go to this part. So this board peak. So check the first range that I just highlighted for you. You can check on your discussion menu, but this board peak should represent OH or NH. And I'm actually talking about the stretching between oxygen and hydrogen or nitrogen and hydrogen. But you don't know if that's an oxygen or nitrogen. You don't know, okay? So the peak in between, those are the CH bond, okay? But there is a requirement for this CH bond, which they need to be sp3, which means single bond. So there's a very special one here, which is the aldehyde peak. So this is the very different, okay, which is the aldehyde. So we are talking about the stretching between this carbon. So basically this one, okay? This is the aldehyde peak. And in a range of 1500 to 2000 is actually going to be double bond. I'll just write carbon. Any questions about this one? We're not going to differentiate that much. But actually in this one, there's a very special, but we are not expecting you to know that because this one is the carbon oxygen single bond stretch. So we know it's more likely to be CO, okay? But it's fine if it's in the exam that you are writing carbon bond. It's fine because we don't expect you to know the fingerprint region. And compound B, so it's a small sharp peak. We know this is also going to be CH, so it's also going to be CH. But this one is going to be the sp hybridization, which means it's the triple bond. So it's this one. So it's still going to be CH region here. Maybe I should draw a line. And then this is the region of the triple bond. So this is the region of the triple bond. So you don't know if it's carbon or it's nitrogen. This one is still going to be carbonyl. So I'll just, okay. Can you explain the double bond in a compound again? Okay, so do you mean that the range here that's I was talking about, that's you actually, so ignore about the carbonyl that might have a special bond here. So ignore about this one. Are you good with double bond? Usually have the range from 1500 to 2000. So this is the range of double bond. For whoever asked that question, you don't have to pay attention to the carbonyl. And let me just ignore this one. So your expectation in IR is only this, and that should be fine. Okay. So the question is, why did you circle the CO bond and check the CC bond? Because I think from our experience, we know it's actually going to be carbonyl. As your circumstance, if you're going to tell me this is a carbon-carbon double bond, I would still mark it correct, because we don't expect you to know that there's a peak in the fingerprint region that can tell you this is a carbonyl. So go practice on your own with this question 3, and we can do it together. Well, if there is something different from my discussion than others, that would be, I always think it's more important for you to know what is not in the IR. We basically is trying to teach you a tool, finally combine IR and NMR. So combine IR and NMR, you are going to tell me what's the compound. So it might be a benzene, it might be something else, whatever, but you need to tell me what the structure is. I know you can identify what's at a functional group in IR, but sometimes it's more important to know what is not in IR, which means when you have some gas in NMR in next week, let's say you think there's an OH group in NMR, but in IR you didn't see that board shape, then you know your OH is not going to be correct. So you know your OH is not going to be correct because you didn't see that thing in IR. So it's always more important to see what is not in IR than what is, okay? So here, it's important for you to know there's no OH, no NH. Just by doing this, you are going to wipe out some of the wrong answer, okay? So this one, it might be a triple bond or something else. Because I know this is also in a region of the triple bond, but let's just put a triple bond here. So it might be, okay? But this region is always going to have a lot of the choice. This one is an aldehyde for sure, aldehyde. I basically can wipe out the answer that doesn't have aldehyde. This one doesn't have, this one doesn't have. Okay, and then what else? In the range of triple bond, I didn't see anything. So no carbon-carbon, no carbon-nitrogen. Then what happened to here? Okay, then this is telling me an information that's this might not a CH stretching of sp hybridization. It might be something else, okay? But just because there are no triple bond in a range of this, there are no triple bond in a range of this, I'm going to wipe out the triple bond. Okay, so what else? In the range of the double bond, I can see there is carbon-carbon or carbon-oxygen. What's more surprising is there are actually two peaks. So it's going to give me an idea that there are two kinds of double bond in the molecule. So I'm going to wipe out this one, because in this one, there's only one kind of double bond, which is the carbonyl, which is this one. I need to see another, which is the double bond of carbon-carbon. So the correct answer of this one would be this and this. Okay, it seems to be very easy, right? So this week is a easy week. We can do more exercise if you want. You do F. So go try to figure out F. So let's do it together. I hope this is not very hard. So first, when you see this one, you're going to recognize it's going to be OH or NH. There are a lot of them is wiping out here. So you just need to choose between these four. So what else? Let's see what are the difference between those. So here I can see this is a, let me change the color. So this is in a range of triple bond. So I know this one is out. So what else? There are no double bond. Okay, the rest of them all meets the requirements of half OH or NH and half triple bond. And then the only difference is actually a little bit tricky, is this one. Should have a very short peak here, right? So what would be the spectrum of this one if it's real? It should have a small edge here, okay? Because we didn't see that, because we didn't see this small edge. So I know it's not this one. So the correct answer of this question would be this two. Do you still want me to do this kind of question, or you want me to go back to do this two? See, this is one of the edge that I was talking about. How about you do C and D? I think that's more interesting. Okay, let's do it together. So this is, we just talked about, it's going to be primary amine, because each of the bond is going to have a NH stretch, is going to have a different peak. So this two represents, so when you see that, it's a very obvious primary amine. And there is a hidden one that we actually didn't explain. Okay, so this one is going to be either going to be carbon-carbon bond or carbon-oxygen bond. We don't know yet, but there's a peak here. Is the sp2-CH stretch. And when I see this, I think it's more likely to be carbon-carbon bond, because if I have a carbon CH bond, this is going to be an aldehyde, and this peak should be here, but I didn't see that. And this aldehyde peak should be here, but I didn't see that. I know this is not. So I think it's going to be carbon-carbon. And this is the carbon-carbon double bond, and it's it's very likely that there's a hydrogen bonding to the carbon-carbon couple. Okay, compound D. So if it's OH, if it's just OH, usually it's going to be like this. Okay, so this is going to be OH or NH. Well, but because I see something like that, this is more likely to be carboxylic acid. You just know it from your experience. And then these two are our sp3 hybridization, CH. Here, in the region of this one, it's triple bond. So it's going to be carbon-carbon or carbon-nitrogen. In the region of here, it's going to be carbon-carbon or carbon-oxygen. And actually, I can tell you this one is the carbon-oxygen. This one is the carbon-carbon. So an easy way to remember this is carbon-oxygen usually have the range around 17,000. So compound G. So that's come to our information that it's more important to know what is not. So no OH, no NH. And then what else? This one suspect to be the triple bond, or it can be the double bond H. But in the region of the triple bond, so in the region of the triple bond, no triple bond. So I wipe out this one. In the region of double bond, carbonyl, carbon-carbon. So I'm going to wipe out for those that doesn't have both carbonyl and carbon-carbon. And oh, there's one more, should have an aldehyde. That's basically we did the exercise together as the back of the discussion menu. So it's really not hard, right? There's a question, why did you cross out the purple one again? Are you asking compound G for whoever asked that question? I'm assuming you're asking compound G then, because in my purple compound, there is no CC, which I did clearly see a CC. There's another question. Will there only be two options for compound G since there is no aldehyde? Yes, because there are no aldehyde. So I wipe out this one. This is a quick discussion, and I hope it's not very hard. Okay, bye-bye. See you guys next week. Bye-bye. Bye-bye.